Okay, so this is kind of one of the last days that I'm going to do a kind of full-blown, like, hey, this is a review. We're kind of past that, and it's going to start being you trying problems and you working through the challenges. And you're going to see your level of success slowly grow, but you will have to adjust your expectation for success. Instead of trying to get 90% correct, you're going to be trying to get like 50% correct, okay? And that's where it's going to be. And you got to do that. And the toughest thing about that is you'll have times where you'll feel like giving up. We need you to not give up. We need you to push through. So here we go. Derivative and integral operations is sometimes something that comes up within the free response section. Not quite as common, but this is a nice review of things you'll see within the multiple choice section as well. So we've covered 6 types of problems so far. This will be number 7, then we'll do number 8. So consider the function f whose graph is given below. Also let g be the function defined by g of x is 1 minus x to the 10th. Notice how we give you both a function rule and we also give you a graph. It says use the following to determine these. H of x be f of g of x and find h prime of 2. What are you going to do? Derivative of h. Yep, that's what we want. Derivative of h. Good. Yeah. Chain rule, very good. And the chain rule says, we have h prime of x is equal to, since this is a composition function, it's the derivative of the inside, which is g prime, times the derivative of the outside, which is f prime, times the inside left alone. Now, I know you're saying to yourself, well, I'm used to setting up boxes. Well, if they write it like that, this is how you got to think of it. Okay, you got to be able to represent mathematical situations in multiple ways. That's what makes it kind of tough. So we're going to plug in 2. So h prime of 2 is then equal to g prime of 2 times f prime of g of 2. So we got a couple things to think out here, okay? First of all, we got to find g prime. How do I find the derivative of that? Yeah, and no problem setting up the boxes there, right? The outside, u to the 10th, inside. Okay, derivative of u to the 10th. Now you get -1, right? So it turns out that g prime of x is equal to -10 times 1 minus x raised to the 9th power. And what am I plugging in for x? 2. 1 minus 2 is -1 to the 9th times -10. So it ends up being 10. So we got 10 here times. Now how do I do that next part? Plug in what? Yeah, to the original one. 1 minus 2, -1 to the 10th, 1. So this becomes f prime of 1. Or in other words, 10 times the derivative of f at 1. We are looking at this graph here. I have 1. What is the derivative of the function at 1? What does that even mean? Yeah, what is the slope there? -2. So we've got 10 times -2. And so you get -20. So that's really not that bad of a problem, but we all know that if we were to counter that just blindly, it's like, holy cow, how do we even do that? Now that you've been taught how to do it, the question is, will you recognize it and see that when that time comes up? And that's why we see the scores so dispersed on the AP exam, is that some people remember that, but a lot of people don't. Let's look at the next one, letter B, k of x. How is k of x different than h of x? Got 5x squared times f of x. Trying to find k prime. Come on. Yeah, you do. I'm finding the derivative, right? Just get rid of the letter. I'm trying to find k prime, so what am I going to use? Yep, I'm going to take a derivative. What am I going to use to find the derivative? The product rule. These are two functions multiplied by each other, right? Let's just use the product rule. So I've got k prime of x is equal to, what is the derivative of 5x squared? 10x times f of x. Okay? And then I have plus what? F prime of x times 5x squared. So that's the derivative. If they wanted you to plug in a value, say it was 1, then we could just plug in 1 for x and evaluate it there. Okay? All good? Not too bad. Let q of x be the natural log of f of x. Write the equation for the line tangent to q at x is equal to 1. Okay? We start with the basics. It's asking us to do what? Write an equation for line. What do I need for equation for line? Slope and a point. So we start with slope and we start with point. What is the x value for the point? 1. How do I come up with the y value? Plug it in. So q, that's g, q of 1 is equal to the natural log of f of 1. What is f of 1? One. Like if you plug 1 in the function, you get 1, right? Okay. So this is equal to the natural log of 1. What is the natural log of 1? 0. Why? Because the natural log of 1 means what? Means e to what power is 1. And what do you raise something to a power to get 1? 0. That's why that's the case. So we do have the natural log of 1 is 0. You maybe also thought about the graph crossing at the spot. Good for you. So we've got our point. Now I need the derivative. So I need q prime. What rule are you going to use to find q prime? Got the natural log of f of x. Chain rule. Yeah. Chain rule. What's the derivative of the inside? What's the derivative of f? F prime. Times, what's the derivative of the outside? 1 over x. Yep, but you put that left alone, right? So 1 over f of x. So I set it up like that. I'll show you another way to set it up if you want to. You could have set it up using your boxes. You could have the natural log of u and f of x. The derivative of f of x is f prime of x. And the derivative natural log of u is 1 over u. Notice how the f goes into the bottom there, and then f prime will be on top, right? So that's all we got to find the slope. We have to just do the derivative of f, and then the function at that spot. So we've already determined f of 1, right? What is f of 1? Yeah, it's 1. The 1? So this is our function f. So as we plug in a value of 1, we have an output of 1. Yep. So we've got, so we know the bottom part is 1. And then on the top, we have f prime of 1. That means the derivative at 1. And we already determined that to be negative 2. So it turns out the slope is negative 2. Is that enough information to write an equation for a line? Yeah, it sure is. So I'm going to write that equation for that line. I'm going to do y minus 0 is equal to negative 2 times x minus 1. And that's my equation for my line. Then all of a sudden somebody throws this there. They say r of x equal to the integral from a negative 3 to t of f of t dt. Determine r of 5. This should actually be an x there, not a t. That's improper notation. My apologies. What does that mean? What does that mean? Trying to find r of 5. That means I plug 5 in for what? X. What does that mean? There's two things that should come to your mind when you see that. Antiderivative. Do we have a shape that or do we have a formula you could take the antiderivative of here? You can't take the antiderivative of this, can you? So, what else does that mean? We've said that that means, so with an A area, That's the area from negative 3 to 5. So I want to find the area from negative 3 over to 1, 2, 3, 4, 5. I want to find the area from here to there. That's what that's asking. You go ahead and see if you can find that area from negative 3 to 5 and find it exact. Ready, set, go. Just dealing with triangles and so I'm going to check this area right there in red. And I know I have 1/2 times the base times the height. And that's equal to 9 times a half or 4.5. Everybody okay with that? Multiple ways of doing it. Okay. I'm going to do this area right here. Looks like I've got a height of 3. So 1/2 times the height of 3 times the length of 1.5. Or 3/2. So looks like out of that group I get 9/4. Very good with that? I'll try another one. I'll try this section right here. I've got another triangle going on. Later. Have a good day. So this is going to be 1.5 or 3/2 is the base. Times a half for a triangle, and times the height is negative 3, right? Aren't those two the same? So this will cancel out with that. So I'm just going to get rid of this stuff right here. I can see that that cancels out. Okay. And if you wanted to, you could also cancel a few other things out if you want to, couldn't you? Like, for example, there's negative 4, right? So I could cancel out that negative 4 with 4 of those. So all of a sudden I'm down to 1/2 plus whatever's sitting right there. And if you find the area of this, well, that is 1/2 times the length of the base, which is 2, times the height, which is 1. And so we get out of that 1, but it is negative. So you add the negative 1. So yes, negative 1/2 is the exact amount. You divide it up however you want. You cancel out whatever you want. You count whatever you want. But you can divide it up and find area of shapes. Yes.
Can you just count it? Like
Sure.
Because that's what I did. I got negative 1/2.
Yep, that's fine.
I think it's supposed to.
Very good. So, right. So, excellent. So, very good. Can I just pose something to you where you might not want to do that?
Yeah.
Okay. So, suppose you get this triangle. Would you agree that that triangle is a little bit more difficult to count? So I give you triangles where, these were slopes of 1 and 2, and that was pretty straightforward. But all of a sudden, this is a slope of, like, what, negative 5/2? So in that situation, you'd want to use the formula for the area of a triangle, right? Okay, so that's why I just showed you that. So without a doubt, that's a situation you can count. But finding area using basic shapes of, you can always divide this stuff up into triangles and rectangles usually. Okay, so we've got that. We got negative 1/2. And now it says determine R prime of 3. Oh boy. Interesting. So you might be tempted to just kind of stare at it. Don't stare at it. Write something down. That's what R is, right? What are you doing to R? You're taking the derivative, right? So let's take the derivative of that and you get R prime. Let's take the derivative of that. What are you left with? Yeah, f of x, right? So R prime is the function. That's one thing you learn. The derivative of the area function is the function that bounds it. So when it says find R prime of 3, you're just looking at the function value at 3. And what is the function value at 3? Negative 3. Function value is negative 3. And now it says, does R have a relative maximum over the interval negative 3 to 5? If so, explain where and justify your answer. What does it mean for something to have a relative maximum, or in other words, a local max? Talk for 20 seconds. Come up with an answer. Go. Five, four, three, two, one. What do you got? What does it mean to have a relative maximum, local maximum? What does it mean? Yeah, wherever r prime changes from positive to negative. Well, what is r prime in this situation? R prime is f, or where f changes from positive to negative. So where does f change from positive to negative? Three halves? Yeah. F changes, so r prime, which equals f, changes from positive to negative at x equals 3 halves. I hope you guys are seeing that a lot of these problems are very doable, but we're not going to remember them unless we go over them. And we're not going to remember them just by going over them. Like, you're going to have to practice some of these, right? Yeah, exactly. Okay. And this is relevant to the material we covered, right? But my guess is you're also thankful that our tests didn't look like that, right? I had a student one time who got kind of critical with me during class. They're like, you didn't teach class well. I'm like, okay, all right, that's fine. It's your opinion. That's fine. I think, can you tell me more? They're like, you should have given us tests like this. That way we've been more prepared. I'm like, okay. I said, I'm going to let you think about that for a second. You want your tests to look like this? Like, that's what you want? I mean, you feel like you're going to do really well with that? And they pause for a while. They're like, you're right. I like the test we had. So, okay. All right. And you guys, the tests that I gave you, I think that those model better what you would see in college. Just because somebody passes a college level math class doesn't mean they'd show up and they get a 5 on the AP exam. That's not what it means. Okay. But we are tough tigers. We're going to embrace the challenge, and we are ready to do it. Last one. Here we go. Last one. Consider a differential equation. Y minus 1 over x. Sketch a graph of the slope field in the spaces provided below. Do you remember how to sketch a graph of the slope field? Yeah, let's just do a few of the slopes, okay? Let's just do like 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And we'll put some dots in there. They will provide it for you, and most likely they will say, they'll just give you like 8 dots that you're supposed to use. They're not going to make you do 20 dots. I know some of you guys were like, do I have to really do all those? We did it during class, but we didn't spend a whole lot of time with it. I don't think anybody was bringing work home with them when we were doing this. But let's just get a general idea of what the slope field looks like. So as I've got that drawn, who can tell me anything about this slope field? I got y minus 1 over x. Okay, I got undefined at x equals 0. Where is x equal to 0? On the y-axis. So therefore, I'm not going to have any slopes along the y-axis. What else can you tell me? Think about the numerator. Whenever y equals 1, the slope is? So y is equal to 1 right here. So all on here, I'm going to draw slopes of 0. And we'll do a couple other slopes. For example, suppose and you can actually make a chart over here. This is part of what they'll look for. They'll say that put your point there, and then a dy over dx over here. So if the point is 1, 1, then that means that the derivative is 1 minus 1 over 1 or 0. So, but we already know that, right? Give me another coordinate that's not going to be 0. Anybody? 2, 2. So I'm going to plug in 2, 2. And when I do that, I get 2 minus 1 over 2, which is a half. So if you make a chart like that, they'll probably give you points, seeing that you're doing what you're supposed to do. That means for the point over 2 and up to, I have a slope of a half. Give me another one that's not in the first quadrant. -1, -1. So I've got -1 minus 1 over -1, or -2 over -1, which is 2. So you can see at -1, -1, I've got a slope of 2. So it looks like you're getting positive values over there. You guys get the idea? We've done that, right? We don't need to proceed anymore, do we? Can we all agree you can get the slope field question correct? Okay, let's move on to something else. Now it says a slope field for the given differential equation is shown above. Sketch the solution curve that passes through the point 1, 0. So notice how they have the point 1, 0 marked here. See if you could go ahead and sketch a curve that matches the slope field but passes through that spot. Ready, set, go. Sketch a curve that you feel like passes through that spot, kind of matches the slopes. And just to be honest, I generally find these to be pretty straightforward. I think this one's a little bit more complicated than just straightforward. Not a big fan of this one personally, but. Okay, 5, 4, 3, 2, 1 should have something like that. Okay. Did you get it?
Yes, I did.
Okay, good. All right, so you can get another point in the AP exam for that. So slope fields, there's a pretty good chance, let's say 70% chance, you're going to slope field question for your free response. We got 2 more to go, and we're almost at time. Let y equal f of x be the particular solution to the differential equation, this guy. Ooh, wow. With initial condition of f of 1 is equal to 0. Write an equation for a line tangent to the curve at f of x, x equals 1, and use your equation to approximate f of 0.7. This sounds ridiculous, doesn't it? So it's actually a pretty easy question. This one comes up quite a lot. I want you to focus on just the main part. What is the question asking you to do? Write equation for line, which means you need slope and a point. So try to filter out all the other things that are confusing you and focus on what it's asking you. Get my point? All right. So you tell me, what is the point that it passes through? Good. 1, 0. Initial condition. That tells us something that passes through. Everybody okay there? In order to find slope, I need the derivative. They gave you the derivative. That's the derivative. They don't give you the initial equation. They give you the derivative right there. That's what dy over dx means. I am the derivative. So if you want to be able to find the slope, what should you do? Plug in the point. So if we plug in the point, we get 1/3 times what? 1 times, what is y? So I got -2 squared. So what is 1/3 times -2 squared? 4/3. Not too bad, right? We now have slope and a point. Can you now write equation for a line? You see how this is actually a pretty straightforward question. It looks super complicated. So we have y minus 0 is equal to 4/3 times x minus 1. Now it says use your equation to approximate f of 0.7. So use your line to approximate f of 0.7. What do you think I do with 0.7? Plug it in. So watch this. Y is equal to 4/3 times what is x? 0.7. 7/10 minus 1. What's 7/10 minus 1? -3/10. So I got 4/3 times -3/10. And you get Negative 2/5. And you really should say f of 0.7 is approximately negative 2/5. Try to let them know what the heck you're talking about. I'm running up against the clock here, so I'm trying to get that done. Kind of a newer question, right? But really not that bad, is it? I actually had that built into our slope fields day. We just ran out of time one day to talk about. Last one. Find the particular solution to the given differential equation with the initial condition. So you guys remember general solutions and particular solutions? Let's do it. Set it up. dy over dx is equal to, to be clear, in this situation, I don't remember. Oh yeah, we're going to use this guy right here. Okay. 1/3 x times y minus 2 quantity squared. So let's just understand we might not get all the points. Let's try to get what we can. What are you going to do first? Good. Yep. So I'll divide the y minus 2 squared over. So I get dy over y minus 2 quantity squared is equal to 1/3 x dx. I separated my variables. Get a point for doing that. Now what do I have to do? Antiderivative. So antiderivative there, antiderivative there. One on the right's easy, one on the left is a little bit more challenging. Let's do the one on the right. Antiderivative 1/3 x. 1/3 x squared over 2. And so if you multiply the 1/3 and then divide by 2, you get a 1/6. So we're going to go x squared over 6 plus a constant. The dx is gone. We're taking the antiderivative. But then on the left side, I've got the antiderivative of 1 over y minus 2 quantity squared. Or, in other words, the integral of y minus 2 to the negative 2 power dy. So I have to use substitution in this situation. It's not bad. What is u equal to? Y minus 2. Please stay through the belt. This will not take long. What is du? 1 dy. So notice in this situation that you just have the integral of u to the negative 2 du. What is the antiderivative of u to the negative 2 du? U to the negative 1 over negative 1? Or negative 1 over y minus 2, right? Actually, I think that you had this problem in your work from your slope field stuff. Okay, I want to solve for y. You could deal with your initial condition right now. I don't say find the general and the particular, do I? So should we find C right now? Okay, let's find C. What do you plug in for y? Yeah, y is 0, so I get 1/2 is equal to, well, I plug in 0 here, I get negative 1 over negative 2. It's okay. What goes in for x? 1, so I get 1/6 plus c. What do I do to both sides? Yeah, I subtract, right? So, and I get 1/3 is equal to your constant. Everybody okay with that? So let's finish this off. We're almost there. Negative 1 over y minus 2 is equal to x squared over 6 plus 1/3. To make life a little easier on myself, I'm going to go ahead and combine those two together. Can I create common denominators? So I have negative 1 over y minus 2 is equal to what if you make common denominators? Over 6. Good. I want to solve for y. What do you want to do to both sides? Times by negative 1? Yeah? Okay, so I get 1 over y minus 2 is equal to negative x squared minus 2 over 6. How do I get the y into the numerator? Or just take the reciprocal of both sides. I get y minus 2 is equal to 6 over negative x squared minus 2. And add 2. Lots of ways you can write this answer, but the particular solution is y is equal to 6 over negative x squared minus 2 plus 2. And as I said, there are lots of ways to write that. I would choose to write it as y equals negative 6 quantity x squared minus 2 plus 2 in that way. So, good job. Way to go. Here's what you need. By next Wednesday. Can we do it by next Wednesday? Is that fair enough? Okay, so then what I need, so that's a week, basically. I need you to do these problems. If you use your notes, circle the problem, so that way you would only give yourself 1 point instead of 2 points. So try the problem without your notes, and then try the problem, and then if you can't do it, then try with your notes and go from there. Everybody got that? So then we'll try to score it accordingly. Again, the people that did best on the AP exam last year, they did best on this. This is an excellent preparation. We did 8 problems. I'm giving you 6 here, okay? Giving you 6. Try to do them without your notes. If you got to turn in your notes, then circle it so we just give you 1 point instead of 2. This will not be graded for you or against you, just a formative thing to see where you're at.